You mentioned binary classification like 20 minutes in. You should be having that discussion maybe 5 to 10 minutes into the interview.
Hey everyone, welcome back to another episode of Whiteboard Confidential. I'm Adam from interviewing.io, and I'm excited to share today's replay with you. In this episode, our candidate was asked by an interviewer from Meta to design a machine learning recommendation system. This system chooses which Instagram Reels to show each user to maximize engagement. This is a great look at what it takes to land an E6 role.
Nowadays, that's the E5 bar. What's different for E6, right?
This interview was for a staff-level machine learning role at Meta, which unfortunately this candidate did not pass as they struggled with time management and other key details. Let's get into the interview.
So I'll give you a high-level problem statement, and I want you to drive most of the discussion around the solution, but feel free to ask clarifying questions as required. So the system we'll be designing today is Instagram Reels. You might have used this product. It's a feed of short videos. So when you enter the app, there's a short video that's playing, and then you can swipe up to see the next one, and it's like an infinite scroll. Yeah. So over to you.
Okay, cool. So first, I think, just so I can frame the discussion a little bit and guide it, I wanted to do a quick outline of the way I want to approach this problem. So first, I want to understand the constraints. So then I want to see how ML can help maybe classify the problem. Then talk about data and feature engineering, how we'll train and build a train set and train the model, talk about serving the quality or metrics. How do we know we're performing well? And then we can talk about any sort of deep dives. Does that sound good?
Yep.
Cool. So, okay, so we have this design reels thing on Instagram. So let's talk a little bit about the the business objective. What are we trying to optimize for? Do we want to increase the engagement, or maybe the show the most ads while doing this, or have the most interactions? What is the high level business case for this?
Yeah. So what do you think?
So we can optimize for views or engagement with the platform, but there are, there are more concerns about long-term health of an ecosystem like this. So we could optimize for quality weighted views or user satisfaction. I think we should maybe try for quality weighted views or interactions. Yeah.
Okay. And how would you define that metric itself?
Well, one approach is to say that we can gauge maybe the quality of a post based on its content, some heuristics on duration or the number of, say, comments on it, or maybe the
Okay, sure, but maybe we take a step back and just look at it again from first principles. So quality weight views is one good metric, but if you had to choose something simpler, what are you trying to maximize here?
Okay. So if we don't want to do long term, maybe we can do that in sort of refinement. We can just maximize engagement with the reels. So maybe the watch time, like some sort of normalized watch time, or the engagement with the platform. through likes and sort of completed views, something like that.
Correct.
So
yeah, that was as a business objective. Yeah.
Okay. Maximize engagement platform as measured by maybe actually it's impressions and watch time. I don't know, or interactions or interactions. Okay, cool. So the other thing we should probably talk about is okay, what is the scale of the system? So how many reels do we get? Are there any like how many users, that kind of thing? So what would be something that could guide us there in terms of the user count, say?
So yeah, it's like 1 billion daily active users.
And daily active users. And what is the creation rate of new reels? Like how many new reels are we creating?
Yeah, we can estimate that, I guess, but I would,
Like,
yeah, it would be sort of 2 orders of magnitude lower than the DAU, like, like 1% of users roughly make a reel. So that's, yeah.
10 million sort of new reels. Okay, cool. And then what regions are we? Is there any regional kind of information we should care about?
It's a global product, but obviously the highest sort of scale is in the US and Europe, but there's also significant presence in LATAM, Africa, Middle East, and Asia.
Okay, so but say also operating in other regions. Okay, and I mean obviously we want these. The hypothesis is that we want to maximize, basically show users reels in some personalized way. What kind of information is available about the users or the reels? Like, do we have, for example, do we make users say what topics or categories they're interested in? Do reels have like tags, or are we kind of learning this in an unsupervised way?
I think we don't have a lot of structured information that is input directly by the user. So we can infer all kinds of things, but from the user point of view, it's very simple in terms of like they're just uploading videos, and like, as a consumer, you're just coming in and watching the videos.
Okay. On users upon creation. Okay, and then and about the videos, we just have video content, and maybe initially just have video content. Do we allow anything like comments or?
Yes, we do allow like likes and comments, and maybe even video descriptions.
Okay, likes, comments.
Those are free form, so there's not much structured input that the user can put in. Like, we don't ask them to choose a category, for example, but they can add free form text.
Okay, so okay, cool. Can I assume that we at least have like location information or like our metadata? For example, like some metadata, like what other metadata would we actually need? Is there any interactions between users that we have? For example, follows or anything like that?
Follows, we do support follows.
Okay.
We can follow the author of read.
How do you spell or support follow author? Okay. Let's see. Is there anything else that we should talk about here? I mean, okay. Maybe this is enough for the initial problem. Maybe I'll go back and refine this as we do our initial design. I like to think about this in terms of sort of an iterative approach. So we can view this as having certain hypotheses and then try to choose a. Oh, actually, one thing I should ask. Is there any system that already exists? Are we building on top of an existing system or data set, or is this the first kind of MVP? What do we have access to? Like,
So we have user data. So let's say we have a heuristic running for ranking, and the whole system is running and has a lot of users. So we have lots of user activity data, and now we are transitioning to a ML-based system.
I see. So we have a heuristic running for on the platform for ranking. Lots of users. So our goal is to maximize or engagement on top of this baseline. Right. So the first thing I was going to ask is, or talk about is, essentially what do we use as the baseline? But it sounds like we already have some sort of simple heuristic. Am I assuming that we, well, we should maybe talk about the metrics that we've been using for this heuristic. So the metrics that we said we were using are sort of engagement as measured by maybe daily impressions or daily watch time of users, maybe by region or by like stratified by some demographic, right? So if we gauge model improvement means that our watch time for like our watch time improves, or the number of interactions with our system improves over time, maybe as measured by like daily, weekly, or in A/B tests, something like this. Okay. All right. So, sorry.
Makes sense.
Yeah. Great. Okay. So then let's talk about. Okay. So this is fairly clearly some sort of ranking problem, where we have a lot of reels that get created. So like the inputs, I guess, would be, so you have an interaction that's like create reel, and we, I don't know, well, actually, inputs to the system are like reel creation, and then like sort of, we don't do queries, but we just do like ask for recommendations for the system, right? And the system must sort of do something with the created reel information, and the output should be something like a ranked list of reels. The other interaction we can have is maybe the create reel, or interact with post, right? Something like this. And then during serving or when working with the system, you ask for recommendations and get a ranked list of reels, right? Okay, so we can talk about a little bit about the data that we're operating on. So the hypothesis is that about like what are the entities? So we have user metadata, like location is maybe the primary one, but maybe also age, gender, things like this. Features like this. We have users interaction history.
Sorry to interrupt you, but before we jump into that, maybe we should think about what is the output of the model and just
Sure.
the overall structure of the training data. Like, what's the ML objective? What's the label? What's the training data format?
Sure. So I was going to do that after the entities, but we can maybe switch the order. So, okay. So if this is a ranking problem, which it sounds like it is, we need to process whatever information that we have and output a ranked list of reels. So there are several ways of doing this. Like the classic one is you can, for each reel and user pair, you can assign a score for relevance, or like the likelihood of seeing a thing, right? And essentially, you can treat this as like a binary classification problem, like given input features and say history and things like this. What is the probability that the reel is relevant? And you kind of then, given a large group of reels that you could show that are on your platform, you can sort of rank them based on the score and show the most relevant things first. So that's one approach. Another approach, does that make sense?
Yeah, that makes sense. I want to understand how you define relevance here.
Sure. So relevance here is like if a user, say, interacts with a post in one of various ways, there's like explicit and implicit feedback that we can get. For example, if they watch the reel to completion, right? So that like you can treat this as a probability. Like, okay, a post is relevant. One of the hypotheses is a post is relevant if a user, when shown it, will watch it to completion, right? So, or like a large fraction of it. So we could treat this as a classification problem where the person finished watching the reel. So another hypothesis is post is relevant if the user follows the author of it, or you could also treat this as a like a regression problem, like what fraction of the reel does the user watch as a like a normalized time, or maybe you can treat this as an ordinal regression problem where like you bin the durations and say you want to watch a large fraction of it. So like the probability that a person watches 5 minutes of a reel or something, or some relevant time bins. Each of these are viable. Is there one that you would like to focus in particular, or would you like me to choose one? Because realistically,
we should choose. Yeah.
Okay, so well, we can focus on a simple version first. So in real systems, I think the trend has been to actually have multi-term objectives. So you actually sort of based on a user, like whatever user information and session information you have, plus the real information that you have, you can optimize multiple tasks for predicting, for example, the probability of a user watching to the end of a reel, or leaving a comment, or sort of sharing, or doing a like. And those are kind of trained as multitask terms. But if you like, we can focus on a single one. Well, I guess you'd like me to choose.
Yeah. Yeah, I think multitask makes sense, but like if you were to prioritize in terms of what signal do you think would have the highest, or what approach do you think would have the highest? Because, okay, fine, it's multitask, but you mentioned like classification and regression separately. So, out of all the things that you said, if you were to choose, like, of course, it can be multitask, but even in the multitask, there would be some tasks that you would train first.
Yes,
Probably
sure.
right. Yeah.
Well, I think very strong signals. Here's the reasoning. So, say that reels are, I don't know, all about the same length, roughly. They're, typically about, like, at most, like maybe a minute. So maybe unlike in things like video, we don't have a huge spread in reel duration. That's an assumption that maybe you can correct. But the duration of watch maybe is irrelevant here. We really just want to see if a person basically scrolls to the next video, which means it's negative feedback. They don't care about this, or they watch to the end. So we can treat this as sort of one term. So it's a positive impression if they watch to the end. So that was probably the one that I would train first, but maybe, and it's probably the simplest to train. Okay. The second term that I would do is probably sort of likes. It's very strong, like explicit signal that a user likes a post. So, but they tend to be very rare. So one is more common and implicit and probably noisy. Sometimes you just watch reels on accident. The other one is very strong, explicit, but has low density. So I focus on the first one first, and then maybe add other features. So if so, then you have a standard sort of classification problem where a user either interacts, or a user either watches to the end, or if they scroll past, then they don't. So it's yeah. And you maybe set some threshold, like if they watch like 5 seconds, you treat it as a fast scroll. Something like this.
So, okay, if we go with that, now what's one row in the training data?
Sorry, could you say that again?
What's one row in the training data?
Oh, what's one row of the training data? Sure. Okay, so we need so we have an ID, a user ID, right? We have their I don't know, some metadata like age, gender, location, and importantly, we should have okay, it's an important predictive feature for their history, but maybe we can leave that out for now, and then make further improvements based on their view history. So the other, so do you want me to create? Okay, so this would be, I don't know, some ID. I don't know, they're 25. We would one hot.
So there's some user features.
Yeah.
So user ID, user features. What else is there in the training data? Like
sure.
What's there in one row of the training data?
Sure. So I think there are 3 entities here. So there's the user. So we have the reel, which we have the video content. We have a description. We have an author, and maybe we have some comments. So I don't know, sheeted with it, something like this. And then we also have user real interactions where we can have different. Maybe actually we don't. We take this out. We can have like user ID, real ID, and then we have a type of interaction like watch. We have a timestamp, and we can have extra fields. We can have other interactions like same kind of user ID, real ID, I don't know, comment. And then similarly, we can have a like, right? Cool. So since our first task so far has been watch, we can actually drop all the other rows and just encode information in various ways. But in our case, a watch is like a positive label, and a short watch or a skip is a negative interaction, right? So if that's the case, we need to build. These days you would build features based on the user, and also you would process the real in some way, and then you'd use the watch interaction as your label set. Would you like me to talk about the feature engineering for some how I would encode these features?
Yeah, just a couple of things before going to feature engineering is like, so positive samples are where the user has interacted with the reel, in the sense they've watched it more than whatever. What are the negative samples?
Scrolling to the next one or ending the session.
So for a user, you have the reels which they've been shown.
The reel switch.
They've been shown, right? Like,
Yeah.
if I've not seen a reel, that's not part of that user ID reel ID pair is not in the training data.
Yes, that's true.
And
So
yeah.
So you're saying how would I actually gauge that? So I could do oops, get this. So we can do in the training data, we can have skip or some.
That's fine. Like, what I'm saying is, like, for a user, you first start with all the reels that have an impression, and then you use the ones where there's a significant watch as positive labels and one where they're skipped as negative labels, right? That's a correct understanding. All right. And how do you split the training data into train, test, and validation?
So okay. So do we have a bunch of these interactions. So right now I have an assumption that there's no learning behavior. So basically, well, if that's true, then we can literally do an agnostic split. So we have some large amount of data. We make sure that we have a representative sample of our users in the training set based on like demographics information. So you can maybe do a stratified split. And right now, I'm not doing anything special with the timestamp. In principle, I know that for these kinds of systems, you want to make sure that you're not peeking at user behavior by having the same user at different times be at basically the in the train split, and then say a future time in the test split, because you can then sort of unmask or get a dependency. You know more about that user than you would with a random user. So maybe said another way, I want to stratify by user ID interactions. So I want to build a test, train, validate split such that users are the same user is only in the sort of one of the folds. That's probably the biggest thing that I'm worried about. The other thing is I want to have a nice mix of the other features so that, for example, we don't only have people from the US in the train set and then people from other regions in the other set. So I would then sort of mix those. Does that make sense?
Makes sense. All right, let's get into the feature engineering.
Okay, so in the feature engineering, well, a lot of the things that we care about are essentially how do you create useful numeric features for the user information, and then how do you actually encode the video content and the description for the real information. So for the tabular features for the user, initially, you do the standard thing where if it's a continuous feature, maybe actually the age itself is not particularly important, but some binned versions of age is useful. For the gender, you do some one-hot encoding information for things like location. I wouldn't, location, you could do a label encoding, but you probably want to have some sort of also binning, like maybe you only care about regions, unless you want to show like very specific content. For the reels, as a first pass, there are a few things you can do for the video content. For example, you can do a video embedding model where you just directly process the video content. Alternatively, you can just ignore the video content itself. You just have a video ID, and then you try to treat this as just you learn an embedding for that video content directly. As a first pass, I would probably do that rather than trying to process the video content. The downside of that is you have a cold start problem if you don't know anything about the video itself. But since we have also description information, maybe we can infer the content based on the description. Right. So maybe as a first pass, I would just treat the video content as an ID. And then the description, I would have some like text embedding model. We can start with something as simple as like fast text or TF-IDF. But these days, maybe you would just use a pre-trained transformer model to create an embedding for that. You can use something like BERT, or if you wanted to use a decoder model, you can actually pool the embedding. Right now, we're not really using the author feature. So I think maybe I want to skip using the author feature for now. We can actually use that for simple heuristics to recommend reels to users based on their like friendship. Okay. Would you like me to talk? Does the feature engineering make sense, or would you like me to expand on something?
Yeah, it makes sense. Is there anything you want to add to the feature engineering? Because you have only like the user profile and reel embeddings, right? If I understand correctly.
Yeah. So, well, for now, okay, it's a question of whether we want to build a very simple model or sort of a more elaborate model. So the standard way of building recommendation systems based on things like this, or at least a decade ago, was sort of collaborative filtering, where you would use maybe some feature information and some video content, or like the real information, and then you would just look for impressions that you cared about, and then based on that you could find similar reels and you wouldn't use the other features. These days, and maybe that's a good approach for an initial system, but these days what you would probably do is you can use the sort of a video embedding that you learn. You can sort of concatenate the description information, and then you would learn a similarity embedding between the user features and the real features, right? Then based on that, you can kind of predict the watch interaction, because users that interact with reels will tend to watch them. Things like this. But generally, for latency reasons, you would build this as an initial stage system for candidate generation. So you would actually pre-train this initial candidate generation system. You would potentially generate a large number of reels that you could propose. And then you would go on to a ranking or a refinement phase afterwards, where you could, in addition to this user information, you also have things like watch history, like things that they have watched before or recently. So you could gauge what their current interest is and sort of dynamically personalize their recommendations. Similarly, if you wanted to, you could expand the video content understanding to beyond the standard embedding. You could, for example, sample certain frames and try to understand the content of the video in a way that goes beyond the just an embedding ID, and then build a ranking based on that. Is that what you had in mind, or would you like me to add extra things?
No, makes sense. Let's get into the next part, which is the actual ranking system itself, and you've sort of explained it a bit. So candidate selection ranking, what model architectures would you choose for each stage?
Sure. So
I understood the difference in the features,
Mhm.
But yeah, let's talk about the model architecture.
Sure. So in the candidate generation stage, generally, okay. Well, generally these days you can start with a simple model where you have basically the some concatenated user features, right? You have your real features. You do some maybe a relatively shallow neural network for processing the features, right? And then you have a like a similarity embedding where you treat the real features either directly as the video ID, or you also process them in this kind of in a separate embedding, like this, and then you do a dot product similarity. So like real and then E user, right? And then you find similar features like this. That's if you do the contrastive learning case, right? So the other one we talked about is more for the ranking. So so I guess here for the contrastive, sorry, before I go on to the ranking step, the candidate generation step generally has okay, so you have users and reels that they interact. So for each user, you have some positive and negative examples for the reels that they've interacted with, as determined by the user reel interactions, right? Generally, they have skipped a lot more reels than they've watched. So you need to balance, you need to watch like the imbalance between positive and negative interactions. And you can do that with basically negative sampling. You can reweigh the positive and negative examples and then sort of train a model that way to train stably. That'll give you the ability to look up relevant reels for a given user based on their features at the initial stage. But you can also use other heuristics to suggest things like reels that are popular within a certain region, or you know, like you're doing an advertisement and you want to show certain reels. Okay, so the for the ranking case, we specifically want to talk about how likely they are to have a long watch versus a skip, right? So we can watch, we can do a more advanced sort of user features where we additionally have like their history or embeddings of reels they've watched in the session, something like this. And then we have a reel, like proposed reel. Unlike the sort of the two tower architecture, now we would sort of have some shared and then, or you know, in the limiting case, we could use a very simple model, but you have some set of features, or sorry, some set of I don't know, neural network layers that is shared, that sort of produces these user features and or takes this user features at the ranking stage and the proposed reel for each element of the list that we want to rank that we got from the candidate stage. And then we so we had previously talked about multitask. For now, let's do a single task. We can for one task, for a single task, we can talk about the probability of positive interaction. So we treat this as a classification task, right? And we train this as a binary cross entropy task. When we add additional tasks, we can have an sort of a task specific head for like probability of like or comment. And we can then appropriately weigh the you know, we can have an objective that weighs these tasks, and the overall score of a reel for a given user based on their session would be given by some weighed probability of these interactions.
Cool. I think we're out of time, so we can end here.
Mm-hmm.
All right. Cool. Before I share my feedback, I want to understand from you how this interview went. What are the things you did well, and what are the areas of improvement?
I think maybe I did the initial um, um, question gathering in a more interactive way than I have before, but I think I really struggled with um, time management and settling on a particular choice. And yeah, I mean, I didn't get through most of the things that I wanted to talk about. I explored a lot of options, but I didn't get down into specifics. I think that's the biggest thing. And I couldn't decide whether to do a sort of a short, like a simple version at the top, or just dive into a more complex, like what I would actually probably build in terms of state of the art.
Right. Yeah, I think those are all very good observations. So overall, subjective sense that I get, from having done a lot of these interviews and also working as an ML engineer at a staff level is like you definitely know your stuff, right?
Mm-hmm.
But I think just based on how this interview went, I couldn't recommend a hire for you, to be honest, right? Like I didn't get enough signal in this interview for E6, and even E5 is honestly borderline, right?
Mm-hmm.
So there are a couple of reasons for that. The biggest reason I would say is time management, and within that, the biggest reason is just the amount of time you spend in the beginning. So just to give you a sense, right? We started like maybe 5 minutes into the hour.
Yeah.
And so like 20 minutes in, which is like 15 minutes out of the 45 that you get,
Mm-hmm.
you're still at this point here. We're talking, and all of these, like this high level diagram was not required. For a second, I felt like you're going into like the traditional system design and you're talking about entities and all this.
Mm-hmm.
Those kind of things, right? So I would just say, and you mentioned binary classification like 20 minutes in, roughly.
Yeah.
And even then, there was a big discussion on binary versus regression, on percentage watched, and multitask. And okay, that was a decent discussion. But, like if you've already, like you should be having that discussion maybe 5 to 10 minutes into the interview, right?
Mm-hmm.
So, like, I think you just need to go through things a lot faster. Like, just understand the problem really quickly, understand the business objectives really quickly. And yeah, doesn't have to be super interactive, right? Like you don't need to ask everything from me. You can just make some assumptions on your own. If you do a wrong assumption, I'll correct you, right?
Okay.
And then that whole part, like the business objective should be over in less than 5 minutes, and ML objective 5 minutes. So 10 minutes in, you are at the point where you're talking about, oh, I'm gonna model this as a binary classification with predicting like a significant watch versus no watch, right?
Mm-hmm.
And they used like as a secondary signal in a multitask approach. So to get to that point should be like no more than 10 minutes, whereas in your actual interview, it took you like 30 minutes almost.
Yep.
Right. And then feature engineering was light. We had to rush through all of that. I think your approach overall of like multitask learning and then multi-stage ranking with candidate selection using two tower and a heavy ranker makes sense. With learnable embeddings on video ID, yeah, those are all good ideas, and you should mention those. Yeah, one more thing you said, like you're confused between the simple versus like the state of the art approach. Always go for the state of the art, especially nowadays, right? Like don't shy away from the complexity or the depth, right? That's the whole challenge of this interview. So think about this, right? If you're like staff level ML engineer position at Meta is pretty rare.
Mm-hmm.
But if you look at the actual loop, right, it's like coding interviews, yeah, those are the same regardless of level. Behavioral is just asking about your past experience, right? So it's these two system design interviews that actually get you the job as a staff engineer, right? And as a memory engineer also, right? Like how do they judge whether you know your ML stuff and also you know it enough at a staff level is just this interview. So it's extremely critical, right? And so it's also very difficult. Right? The problem itself is pretty high level, it's pretty tough. And in 45 minutes, you have to be like the other guy has to be like sort of impressed that, oh, this is amazing. This guy was able to do so many things in just like 45 minutes.
I see.
So
Okay.
by that criteria, like you're still missing a lot. And like, okay, let's say you did what your original intention was. Let's say you had enough time to complete the design, right? Even then, I would be so like, even if you take the time management aspect out of it, let's say you did like proper feature engineering, you had more time, you did the multi-stage ranking, learnable embeddings, everything. Like nowadays, that's the E5 bar. What's different for E6, right? It's like things like the training data, right? Like the time-based split. Yes, you did mention that, but you were not, the way you said it didn't give me confidence that you understand what's happening there, right? So, like, you were very vague and sort of not confident about your answer on the time-based split on training data, right? And also, like, there's no exploration, there's no freshness, right? Remember, the users only seeing the reels that we give to them, right? It's not like a normal feed or YouTube or something where you can search, their categories and you can browse. There's a lot of emphasis on browse usually. So, users can go ahead and explore videos and watch them, and then you can get a hold of their preferences. But in this sort of system, the user only sees what the system serves.
Yeah.
Right. So there's a very high possibility of like bias. Like your training data is the output of the model from a day ago. So, if a model starts missing something, that whole bias can sort of propagate. And so like maybe certain topics are underexplored, right? So so I think these are
Viral.
future explain. So what's the bar, right? Like bar is you complete your design, which is the reasonable design, with like good amount of depth, covering all the sections that you said. So you just got till like this point here.
Yes.
Breathing or training, you're like serving quality deep dives, everything in 45 minutes. And then you're also able to talk intelligently about some of these considerations like exploration, like splitting training data into train and test. Then like feature drift, right? Like, how do you actually get the feature values in the training data? Like, do you just recompute them? If you recompute them every time, then you're also enabling some data leakage, right?
Because okay.
For example, you have a user watch history. Now, in multiple days of data, obviously, if you pick a day, the feature value at that point should be the watch history till that point, right?
Yes.
So if you just like have a feature store where you have like latest user watch history and you use that feature everywhere in the training data, that won't work, right? But that's an important detail which gets missed.
I see.
Yeah.
So the other, so I guess, so I had done one before, and what I was trying to aim for, some of the reason I was hesitant about the timestamp was I was not sure if I could afford the time to explain in detail, but I mean that just speaks to more time management problems. But in a previous interview, I was told that one of the marks of an E6 engineer may be a bias towards simpler solutions that sort of solve the problem initially. But maybe this is just a difference in strategy. Like you can either be, very, I guess, impressive. I like in particular, if you've worked on these systems before, like the state of the art, or yeah, I guess.
Yeah, I mean, that's part of the journeys, right? So I understand your confusion. I also understand the previous feedback and my feedback. So let me try to put it a bit in context, right? So what do you mean by simple, right? Like, for example, the idea of watch history, where you take the embeddings of all the previous videos and average them or something, and that's a watch history. It's simple idea, isn't it? It's not very complex, like, to be honest, right?
Yeah.
But it shows an understanding of the underlying concepts. Right? It shows a deep conceptual understanding. Like, otherwise, someone who doesn't understand how embeddings work wouldn't come up with this idea, right? So that's the notion of simplicity. Simplicity doesn't mean old or another. Like, simplicity just means that you're not overcomplicating it. For example, like a good example of where you showed simplicity here is kind of your whole approach to the label towards the end, right? Where you were like, like after considering everything, I'm like, I just want to know if they swiped or they watched for a significant time. And that's a binary label. And then I have likes, which is a stronger signal, but that's more sparse. So I'm combining both of these things, and that solves 90% of the problem. That's the simple approach.
Okay.
Now, MTML approach with learnable parameters, of course, is way more complex. So, but yeah, that's where you realize that, the simpler approach gets you most of the way and leads to a productive discussion, right? But then don't confuse simplicity with missing important details, right? So you can choose the level of complexity of the solution that you want, but then when you describe a solution, you need to know all the details of it, right? And then the kind of problems that I've described, they are more to do with just mostly like 90% of machine learning is just data. How to deal with the data, right? So like there you might expect like some more higher level conceptual thinking, like the things on the split and all of those things, right? So what was the thing with the timestamp that you were not sure of? Because you were like explaining it to take too much time. Is that the...
Yeah, so I was waffling first because I said initially I know that the timestamp like feature drift, especially if you're releasing multiple models and there's feedback issues with these systems, that this is an important thing to watch out for. In fact, since like 2017, when they talked about the YouTube algorithm or whatever, they mentioned that label leakage or whatever leakage due to mismatched timestamps was a big problem that they had to solve. But my initial statement, I wanted to just stratify based on like age, gender, and location, because I would expect that if you're only good in one region and yet you need to sort of deploy everything across multiple regions, like regional information is important at this scale.
But the feedback loop is also important. And see, that's the part of the seniority signal, right? You don't add complexity for complexity's sake, but you know where it's important to add the complexity, right? So the reason why feedback loops are so important here is also like the context I gave you. This is not YouTube.
Yeah.
Right? Because YouTube has categories and all those kind of things where a lot of surfaces and the interface is built in a way where you can go and explore.
Yes.
So you do get enough signal about the user. So you can assume that whatever videos the user has seen is more or less from an unbiased sample. Of course, some things are, amplified more than others, and that always happens, right? But at least more than Reels, right? Reels is like literally just see one video and then you swipe. So you have no control, more or less, over like choosing your own path in terms of what you want to see. Right? It's a very extreme thing on the other end.
Yeah.
So feedback loops become way more important. Right? So it's important to solve it.
Yeah, for sure.
And
Okay, cool. I've actually.
listen, that so drawing this link and recognizing this problem is part of the seniority signal, I would say.
I see. So, for example, at the start, so I maybe focused on too much detail there, talked about too much, talked about too many options there. I should instead focus on, say, okay, cool, we want to maximize engagement, or like impressions of reels, or interactions. Okay, and then we talked about a little bit about scale, but the point is that this is multi-regional, so maybe we have to build a model per region or something. But the important aspect of the interface is that you don't get to, you have intrinsically a lot of feedback when you show only reels, and the only signal you get is whether they watch, like, or they scroll past. And therefore, your model sort of changes the data that you collect. How do you deal with that? Okay.
Yep.
Got it.
That is a very important consideration in this sort of system. And contrast that with the quality thing that you said, like the long term, right?
Yeah.
That thing I would put in the category of like adding complexity, maybe. In the sense, yes, it's an important consideration, of course. You want to evolve your system one day to reach that, but it may not be like something that has like a 5 to 10% difference in the accuracy. Maybe it has like a 1 to 2% difference towards a long tail, right? Like, again, you have a really good model. Once you have a really good model, these things start to matter, like the long term. And you can talk about such considerations towards the end, maybe once you have like the design working.
Okay, cool. So, in short, just breeze through the design. Maybe part of this is I've never seen this reel, design ever. I'm relatively.
That is not a easy problem, to be honest. And I'm not even sure whether Meta actually asked this problem in the wild as much. They definitely asked a newsfeed version of this. But I know from having worked there, like this system was like very different in terms of the design when we actually did it, right? And I think Zuck spoke about it as well. Like it took them a while. They first tried to take their newsfeed models and adapt them to Reels. That didn't work. And the lessons from that were learned were like all these feedback loops. And the other thing about like friend network based recommendation versus just like interest based recommendation, right? So Facebook is all like based on your friends or your network, like what did my friend like, I might like the same thing. Whereas Reels is like, yeah, I just like X, so show me X out of our universe of all the videos, right? Regardless of what I don't have any notion of friends or anything like that here.
Yeah. So I guess for next time, okay, time management and just going through some more of these case studies, but don't shy away from complexity when it's warranted, but try to nail down the nuances of the problem very early, and then solve them in a minimal amount, in a minimal way. Is there anything I should have particularly emphasized in the training data section? You mentioned that are there any other features you would like to use? Did I capture the majority?
You had the real ID based learnable embeddings, but watch history kind of learnable embeddings, right? Like once you have learned embeddings of videos, you can also have learned embeddings of users.
Yeah.
And you can then have all kinds of cross features. Like for a user, you could have their watch history. For a video, you could have list of users who like this video, kind of similar, like
embedding them.
Corresponding, yeah. So like you only had like video ID learned embeddings, but if you take that concept of ID based embeddings, there's a whole universe of features you can build on that.
For sure.
And the whole category of features that you missed were just simple ratios and counters. So I know you asked early on whether there are hashtags and categories. I said no, but even if there are no categories, you can always assign categories. Either you can manually label them, or you could even like cluster or something and get like sort of derived categories. And then you could have like, okay, in the same category as the reel, how many watches does this user have? Like just numbers. And what's the what?
Category.
Yeah, so the simple numerical features of ratios and counters kind of was missing.
So for you, what would be more important? Basically, diving into more of the feature stuff. I'm just trying to get a sense of strategy. So if I go through the design,
training data is an important signal for leveling and conceptual understanding. But feature engineering is required for completeness reasons. So if your feature engineering section is too light, you might just get rejected. Whereas if your training data section is too simple, in the sense you don't handle the time-based split or the feedback loop, or you don't talk about those considerations, then you might get down leveled, right? But yeah, so I would say like a basic level of feature engineering has to be there. And I think you're almost there. The only glaring miss was on the ratio and counters. Like there's no ratio, no counters at all in your design. Right?
Yeah.
So beyond that, like once you have the basic level of feature engineering, like in the sense you have ticked most of the boxes or themes, like having like a very exhaustive list is not particularly required. It's more about understanding what techniques you're familiar with on feature engineering.
I see. Okay. And then we didn't even get to the serving or gauging the quality. What is I want to avoid generating basically a system design for serving, even though I have some familiarity with that. Are there any basically leveling or sort of criteria for those?
I think serving and all is fine. You can just go with like sort of generic answers, but typically like what I don't know how to bucketize this as in terms of serving or evaluation or whatever, but more on the practical aspects of okay, fine, like at the end of this, you would basically be at a level where you have a model in a notebook, kind of, right?
Yeah.
Or somewhere in some interface where you have a bunch of data, you've trained a model. Now, what's the step from there to actually have a working system that's running in production? And understanding some of those nuances of like when you productionize what happens, right? So there are some nuances around serving, there's some nuances around retraining and data management, feature management. Like particularly I would focus more on the data related aspects, like how do you prevent feature drift between training and inference?
Yeah, so is an example of this, so I talked to a friend about this, but is an example of this that I guess I'm not sure how to talk about this in the context of the whole interview, but very often use different training systems versus serving systems. And in order to avoid basically changes or mismatches in processing like the data, literally the features that you use between training and production, you could actually reuse the same features and your training data literally comes from a production system and you just
Yep, that's a good example. So that's one thing that's like an important detail, right? And the other thing is probably like, okay, what if something goes wrong? What's your process of figuring out like how do you go from, our watch time has declined to like there's a problem in the model or a bug somewhere. Hey, what is the process you follow to do that? That's the other practical aspect.
Okay. And what kind of things could we do? Is this like basically tracking
drift and things like that?
Sorry?
Mostly around data drift, like anything
So like monitoring features and things like this?
Yeah. Exactly. And the thing that you mentioned is also relevant here a bit. But there are other things as well, like like user interest changed, or some popular features came, some popular events came on, or something like that. Like, yeah, just like what can go wrong, and how do you get to that point where you know what went wrong. Like usually, like data drill tell, like just looking at changes in the feature distribution, adding monitoring to the feature value.
Yeah.
and stuff. Yeah.
Okay. Cool. Yeah. So maybe the deep dives becomes the real world problems section where we can talk about kind of how to troubleshoot certain things. And okay.
There are all the practical aspects of, like, someone has a model in the notebook versus is a production ranking system. Like, and not going too much into the details of like system design as such, like in the sense of like the distributed systems. Like, don't go too much into like serving rate, like all those aspects. Talk more of a data related and ML related aspects of it, right? Like, feature driven. It's mostly features, right? Isn't it? Like, yeah.
One thing that I'm not sure about in a practical settings is so you have, if you're retraining a model every day, for example, or every week, essentially how you actually roll out this model to new users, and then how do you roll back and detect, like, do you do A/B deploy, or like canary deploy the model?
It's a combination of A/B testing and monitoring, right? So you obviously A/B test before you launch, and then you also run back tests after you launch because of the feedback loop. And you have monitoring on all the features and stuff. So yeah, those will cover that aspect.
Is there any is it typical to actually use or back test old models, or for example, I don't know, just do a random periodically, just do random videos, or maybe like popular videos, bypass the ranking model?
And those are usually used for measurement. At meta scale, you won't have a proper popularity holdout, but in lower scale systems, it's pretty common. Like the one that I work with, we have a popularity holdout, and that's just to benchmark the gains that we're getting from the ranking system.
Okay, so you want some way of like breaking the feedback loop, or measuring the effect of the feedback loop based on models by sort of bypassing it somehow, or doing random ranking or something.
Yeah.
Okay.
Typically, it handles the training data itself, like just injecting some amount of random user real pairs in there, just for exploration. And then in practical settings, you could also combine exploration with exploitation using something like bandits.
I see.
But yeah, those are more advanced techniques. Yeah. Cool. I think we're out of time as well. So
yeah. But thanks a lot. You could maybe highlight the most important feedback that I don't have very much time to prepare, so I'll do my best, obviously. But if you could tell me some of your feedback, that'd be great. Otherwise, this is very useful. Thanks.
Best of luck for the interview, and have a nice day.
All right, that's all we have for today. Thank you for watching. And if you want to get immediate feedback from the same people who make hiring decisions at companies like Google, Meta, and OpenAI, hit the link in our show notes to book your session now.